Hello class, today we're going to talk about the normal curve. Let's have a quick recap of what we have talked about last class. We discussed the population sample. So population is the set of all items that possesses a characteristic of interest. And a sample is a subset of the population. So if we draw a sample, and the statistics of the sample can make influences on the population parameters. On the other way around, if we have some knowledge of the population, then we can make analysis of sample. We can test if the sample is actually drawn from the population. The normal curve or normal frequency distribution is one type of population, and it has wide applications in the nature and also in industry. So like the heights of human beings, the life of 60-watt light bulbs, the diameters of steel pistol rings. So the normal curve is developed from histogram when the sample size becomes larger and larger and the cell intervals becomes smaller and smaller. So when you go extreme, then you have infinite number of samples, and then each cell is very, very small, so you can view them as continuous variables. So here is a graph of a normal distribution, and the parameters that describes the normal curve are the mean, which is denoted as mu, and also the standard deviation, denoted as sigma. So this curve shows the normal distribution for resistance of an electrical device with mu equals to 19 ohms and sigma equals to 2 ohms. So the horizontal line shows the positive values that the resistance can take, and the vertical line shows the frequency of the different values. The normal frequency distribution holds a lot of nice characteristics. First, it is symmetrical, so half of the cases are to the one side of the center and the other half is on the other side. So they are same weighted on both halves. And the distribution is single peaked. It has only one peak at the mean, and the mean and mode and median are all the same. This normal curve is also known as the Gaussian distribution. From the normal curve, we can tell that most of the case will be close to the mean, and there are just very few outliers at the tail of the distribution. So let's have a look at this normal distribution. So here is the graph for a normal distribution, and this mu stands for the mean, right? It's in the center, and this plus 1 sigma means the data point as mu plus 1 sigma, which means this one is one standard deviation above the mean. Okay, so this 1 sigma, 2 sigma, 3 sigma stands for the dispersion of this data point from the mean. And this percentage holds correct for all normal distributions. So 68.26% of the population is in the range between mu minus 1 sigma to mu plus 1 sigma. Now, if we examine the range from mu minus 3 sigma to mu plus 3 sigma, then 99.73% of the population is in this range. Therefore, we can tell that there are only 0.27% of the outliers are those data that is too large or too small, like extreme data points.